Now we're going to take a look at some tables, and we're going to try and write the linear equation from a table. We've done this a little bit before, but we're going to take it to the next level. So again, keep in mind we're trying to write linear equations, so it is y equals mx plus b. We're still looking for the same old information, a slope and a y-intercept. Last time we did this process, we would find the slope from looking at the pattern or the differences in both the y's and the x's, and remembering that slope is found from the change or difference in y divided by the change in x. So previously we found the patterns over the intervals. We would say from 5 to 3 it went down 2, 3 to 1 it went down 2, 1 to -1 it went down 2, -1 to -3 it went down 2. On x it went up 1 every time. And so our slope is found from change in y divided by change in x, so it would be -2 over 1, which is -2. Then we had to remember specifically that a y-intercept happens when x is equal to 0, because we looked at it a while back. If I have a line and I am looking for the y-intercept, no matter where it is hitting this y-axis, the value of the x-coordinate will always be 0. Because it is not going left or right. That point is only going up or down. So a y-intercept is always 0 and then the number where it is hitting the y-axis. So that information allows me to look through a table and see if they're kind of handing it to us, see if there are any zeros for x, and I see one right there. So that tells me the y-intercept for this particular line is actually 5. So b is equal to 5. So this one is not so bad. That's our old way of doing it. We would write our equation and we would say y is equal to -2x plus 5. We've done something similar to this already. But what if you do not remember this little piece about x being 0 tells you the y-intercept? You might feel stuck. Well, we're going to try this a different way. Instead of doing the changes in y over the changes in x, we're going to use this new skill that we've found of trying to write the linear equation from 2 points. Now this particular question isn't saying, is this linear? They're simply giving us a table, telling us it's linear already, and telling us to write the equation of the line from this table. So I'm not testing to see if it's linear. I'm just trying to write the equation. So when that happens, you can actually take any 2 points from this table and do the process we've been doing. So keep in mind, these are all ordered pairs, 0, 5, 1, 3, 2, 1, 3, -1, 4, -3. You can use any combination of any 2 of these points and get to the equation of the line. I would probably use 2 of the easiest looking ones. I would avoid negatives, pick smaller numbers, but any route will still get you there. So say we use 0, 5, and just to prove it doesn't have to be right next to each other, I'll use the point 2, 1. So say we didn't even have this table. We just had these 2 ordered pairs. We already know how to do that. So now I'm just using this same process just in case you forget how to do it from the entire table. So we're looking for a slope, a y-intercept. I have 2 points. I'm going to use the slope formula. I'm going to do y2 minus y1. So I've got 1 minus 5. Over x2 minus x1, which is 2 minus 0. 1 minus 5 is -4. 2 minus 0 is 2. And -4 divided by 2 gives us a slope of -2. Previously, when we had 2 ordered pairs, we were picking one of the points to use for an x and a y value. I would pick the first one and say that x is 0 and y is 5. And to find the y-intercept, I would plug it into that formula we've been using of b is equal to y minus mx. So b is equal to the y-coordinate of 5 minus the slope of -2 times the x value of 0. Multiplication has to happen before subtraction, so b is equal to 5 minus -2 times 0 is just 0, so b is equal to 5. The same process still works. We picked out two ordered pairs and did the process we had done on examples 1 through 4. I now have a slope and a y-intercept, and I can write my equation y equals negative 2x plus 5. We got the same answer as the previous version. So in example 6, it says, what if the table doesn't show the y-intercept? So we already know we can still find slope from our changes in y divided by changes in x. But when I look for the y-intercept, I don't see any 0 values on x. So in this case, there is more than one way to do this. Some of you can notice that once you find the pattern, you can follow it backwards and figure out where x is 0. That's totally a viable option. Sometimes, however, the y-intercept doesn't end up being a whole number, so that method can be tricky. So let's look at an alternate method that will work every time. So instead of doing the changes in y divided by the changes in x, we're going to just pick out 2 points, because this will work every time that I know the table is linear and they want me to write the equation of the line. So I'll pick the points 2, 5 and 4, 8. So I've got those two ordered pairs. I'm going to write the equation of the line. I'm going to do y2 minus y1 divided by x2 minus x1. So I've got 8 minus 5 is 3, 4 minus 2 is 2, so our slope is 3/2. To find the y-intercept, we're going to do y minus mx. So the slope is equal to picking any of these points here. In fact, I could use 8, 14 if I felt like it, but I probably wouldn't. I'm going to use the smallest point I have. I'm going to say that the x is 2 and the y is 5. So we've got 5 minus the slope of 3/2 times the x value of 2. Again, we have a fraction. We got to remember you're multiplying numerator across, denominator across. Since 2 is a whole number, it has a 1 underneath. So following order of operations, we're going to multiply first, and we've got b is equal to 5 minus 3 times 2 gives us 6, 2 times 1 gives us 2, and really 6/2 is 3. So we're really looking at b equals 5 minus 3, which is 2. So we've got our y-intercept, we've got our slope, and our equation is y equals 3/2 x plus 2. Alright, example 7 is just a table facing the other direction. You would try the same method. You could do change in y over change in x to find the slope, and then you could just pick any of these points. So let's do that instead, just so you can see an alternate method. So say I don't want to just pick 2 points and do that. Say I want to use the pattern method. So from 10 to 6, it's going down 4. 6 to 2, it's going down 4. 2 to negative 2, it's going down 4. 2 to negative 2 to negative 6 is going down 4. These are the changes in y. Changes in x, from negative 5 to negative 3, it added 2. Next interval adds 2. Next interval adds 2, and final interval adds 2. So if slope is change in y over change in x, our slope is negative 4 divided by 2, which is negative 2. Now, I could pick any of these 5 ordered pairs and do this process of finding b using that y minus mx. So I'm going to use any of these points. I like the point 1, negative 2, so I'm going to use that. So I'm saying that x is 1 and y is negative 2, and we already know our m is negative 2. So we've got b equals y is negative 2 minus m also happens to be negative 2 times x is 1. So solving this using order of operations, do your multiplication first. Negative 2 minus negative 2 times negative 1 gives you a positive 2. Negative 2 minus 2 gives us a y-intercept of negative 4. So we've got our slope, we've got our y-intercept, and our equation is y equals negative 2x minus 4. So you've now learned several different ways to write an equation from 2 points or a table. There are multiple ways. You just figure out which one works best for you and which one you are most likely to remember.